Welcome to The Explainer. When you look up at the night sky, have you ever just stopped and wondered, how did all of this happen? Well, today we're going to find out. We are going on a grand tour of our cosmic neighborhood from its wild beginning all the way to its eventual end. So let's kick things off with the biggest question of all. Before the planets, before our sun even existed, what was actually here? How did we get from, basically nothing to everything we see today? All right, believe it or not, our story starts pretty quietly. About 4.5 billion years ago, there was this absolutely enormous, cold cloud of gas and dust just hanging out in space. It was basically the leftovers from long-dead stars. And then gravity started to do its thing, and this cloud began to collapse in on itself. That right there, that was the tiny seed that would eventually grow into our entire solar system. And from that one collapse, boom, our solar system was born. We're talking about the sun, all 8 planets, who knows how many moons, asteroids, comets, the whole shebang. And they're all locked together in this beautiful gravitational dance. And that's exactly what we're going to explore. Okay, so let's get into the nitty-gritty. To really wrap our heads around our solar system, we've got to turn back the clock, way back, and see how it all went down. Now, this is where it gets really wild. Look at the timeline here. It all started about 4.5, almost 4.6 billion years ago. But the really amazing part? In just the next 50 million years, which I know it sounds like forever, but in cosmic terms, it's just a blink, the center of this collapsing cloud got super hot. It formed a protostar, which would become our sun, and then it just ignited. Nuclear fusion switched on. And the rest of the stuff, all that leftover dust and gas spinning around it, that's what clumped together to become the planets, including our own. It's an incredible story of cosmic creation. So, let's talk about the star of the show. Literally, the sun. Because you can't really understand the solar system without understanding just how much of a behemoth it is. And it is impossible to overstate its dominance. And this chart just says it all, doesn't it? Look at that, 99.86%. That is the percentage of all the mass in our solar system that's tied up in the sun. Everything else, Jupiter, Earth, all the asteroids, you and me, we're all part of that tiny little 0.14% sliver. It's not an exaggeration to say the sun is the solar system. Okay, if that percentage isn't blowing your mind, try this number on for size. You'd need almost 333,000 Earths stacked up just to match the mass of the sun. It's just staggering. It's the gravitational anchor that holds everything in place. No question about it. So that massive star and all its energy had a huge consequence for how everything else formed. It basically drew a line in the sand, or I guess a line in the dust. We call it the frost line. Think of it like this. Inside that line, it was way too hot for things like water ice to survive, so you only got rock and metal. But outside that line, it was cold enough for ices to freeze and stick around. This one simple fact created 2 totally different kinds of planets. All right, let's start our tour close to home, inside that frost line. This is the warm, rocky part of the neighborhood, where planets were built out of the tough stuff that could handle the heat. So here they are, the inner worlds. You've got Mercury, the little scorched planet closest to the sun. Venus, a toxic hothouse. Our home, Earth, with its amazing liquid water. And of course Mars, the cold, red desert. And right on the edge of their territory, you find the asteroid belt. It's basically the rubble of a planet that tried to form but couldn't, thanks to the massive gravitational bullying of its neighbor, Jupiter. Okay, so once we cross that asteroid belt, everything changes. We're now entering a whole new realm, the land of the giants. And these worlds are on a scale that just makes the inner planets look tiny. And here are the titans themselves. Jupiter, the king, so massive it's more than double all the other planets combined. The gorgeous Saturn, with those iconic rings made of ice and rock. Then you have the ice giants, Uranus, which is so weird it spins on its side. And finally, Neptune, the cold, dark, and most distant world. And get this, just these 4 planets account for 99% of the stuff orbiting the sun. Jupiter and Saturn alone are over 90% of that. They are the true heavyweights. But wait, we're not done. A lot of people think the solar system just ends at Neptune, but that's not even close to the truth. Our journey continues, way out into the cold, dark frontier. Welcome to the Kuiper Belt. It's this huge, donut-shaped ring of icy debris, basically the leftover building materials from when the solar system formed. You can think of it as a way bigger, icier version of the asteroid belt. And it's packed with thousands of tiny, frozen worlds, including some familiar names, like the dwarf planet Pluto. And out here in this icy darkness, you find some really cool stuff. For example, there's a dwarf planet named Orcus, which astronomers call the anti-Pluto. Why? Because its orbit is almost a perfect mirror image of Pluto's. It's this beautiful, intricate dance showing how everything, even way out here, is connected by gravity, all locked in a rhythm with the giant planet Neptune. All right, so we've taken the grand tour. Now let's just zoom all the way out and really think about our place in all this and what the future has in store for our home. If you really want to grasp just how enormous and empty our solar system is, try this. Imagine shrinking the distance from the sun all the way out to Neptune and making it fit on a 100-meter field, like a football field. On that scale, the Earth wouldn't even be a grain of sand. It would be smaller than a flea. It's just a humbling perspective, isn't it? Our home is a tiny speck in a vast, empty expanse. Our solar system has been pretty stable for a long, long time, but it won't be that way forever. In about 5 billion years, our sun is going to run out of its main fuel, hydrogen. When that happens, it's going to swell up into a red giant, becoming something like 260 times bigger than it is now. It'll almost certainly swallow up and vaporize Mercury and Venus. After that, it'll puff away its outer layers, creating this beautiful thing called a planetary nebula. And all that'll be left is the core, a super dense, Earth-sized cinder called a white dwarf. So that brings our grand tour to a close. But the real journey of discovery, that's only just getting started. Our solar system has been around 4.5 billion years. What secrets are we going to uncover in just the next million? What other mysteries are hiding out there in the dark? The answers are out there, just waiting for us to find them.